In this video, we're going to consider linear equations graphically. Linear equations don't make the most interesting graphs. The graph of any linear equation is just a straight line, maybe like that, or like that. Could be horizontal. So linear, let me label my axes since they're also just straight lines. Linear equations have straight lines as their graphs. And let's just look at the rate of change m and the initial value b. And let's consider those now from a geometric perspective. Let's start with m. We've called m the constant rate of change. When we're considering linear equations graphically, we usually call m the slope. And the slope controls a few things. We'll discuss it in a little more depth in a later video. So for now, let's make the observation that any straight line can have one of three forms. If you think of reading a graph like you would a book from left to right, it can go up, it can go down, or it can be horizontal. That doesn't really look super horizontal, but it's supposed to be. And which of these three cases you fall into depends on m. If m is 0, it's a horizontal line. If m is positive, it goes up. If m is negative, it goes down. M also, in addition to controlling the general shape, controls the steepness. So the larger, how should I put this? The larger m is in absolute value, the steeper the line. So hopefully you've seen absolute values before. What I'm trying to convey with this, if you haven't, is that I want to think of something like 1,000 and negative 1,000 to both be large numbers. And I want to think of something like 0.5 as being a small number. And of course, properly speaking, negative 1,000 is smaller than 0.5. It's to the left of it on the number line. But when I talk about large and small here, I'm ignoring whether the number is positive or negative and just looking at the numeral. So, for example, just sketching. Actually, what we could do that might be nicer than my kind of mediocre artwork. We could go to Desmos.com, which is an online graphing resource, and we could look at like y equals 0.01x. So 0.01 is a small number. This is not a steep line. It's close to being horizontal. If you compare it to y equals 10x, that's much steeper. And likewise, negative 0.01x versus negative 10x. 10, come on, highlight. 10 is bigger than 0.01, which causes this line to be steeper than this line. So that's the slope in essence. We'll talk about details such as how to find the slope later. Let's look at B. Let me see, I'm trying to share this. Well, B is the y-intercept, or more properly speaking, the point 0, b is the y-intercept. Remember that y-intercepts are points. So if you have like y equals 2x plus 4, that tells you that this point where it goes through the y-axis is 0, 4. Y equals 1/2 x minus 2. It will go through the through the y-axis at 0, negative 2. And that's an output line of how how M and B control the graphs. We'll talk about the slope in more detail in the next set of notes.